want to find out if this station, soldering station, is going to work with this, the soldering gun. It's time to build a controller for the gun. I think I have all the parts ready, and this is going to be a front panel where all the controls are going to be. At the back of the front of this panel, I'm going to fix screen, socket, and then some controls that allows me to use the soldering gun. What I've done already, I've soldered and glued a Arduino Nano to the back of the 1.3 inch OLED screen, and now I'm going to fix this screen with a Arduino to the back of this plate. Okay, so the screen is in its place, and this is the Max 6675 thermocouple decoder that is going to sit here. So I need to find a screw for that. And the next job is going to wire this board to the Arduino board. So I have some wires prepared, cut them to length, and what Max 6675 needs is 5 volts and ground from the Nano Arduino board. And then we'll have 3 wires for SPI communication. So it's going to be number 10 for chip select, number 12 is data out from the Max master input for the Arduino board. And then number 13 is clock for SPI communication. And at the moment I'm going to solder them, all those wires in. I want to put a potentiometer that I will use on an analog input as a voltage divider to select the temperature. So that's going to be my next job. And then connect a switch that will put a station to standby, and that's also going to be soldered to the Nano board. So we have potentiometer wired to the Arduino, and the next thing is to have this switch that is going to put the station to standby mode. It's going to activate the standby. So that's another thing that I'm going to wire to Arduino. So I finished wiring up the Arduino Nano board. So in summary, the 1.3 OLED screen is wired to the I2C communication, plus it takes 5 volts from the Arduino board. Then we have thermocouple converting board, temperature decoding board, which works over SPI with these 3 yellow wires and also 5 volts power supply. And then we have 10K pot wired to analog input 1 for setting temperature through the voltage divider, and the other pins are 5 volts and ground, and we have this switch that is wired to ground. The digital input pin number 3 will be pulled down to ground when this switch is activated. So I finished wiring up the Arduino Nano board. So in summary, the 1.3 OLED screen is wired to the I2C communication, plus it takes 5 volts from the Arduino board. Then we have thermocouple converting board, temperature decoding board, which works over SPI with these 3 yellow wires and also 5 volts power supply. And then we have 10K pot wired to analog input 1 for setting temperature through the voltage divider, and the other pins are 5 volts and ground, and we have this switch that is wired to ground. The digital input pin number 3 will be pulled down to ground when this switch is activated. This is the I call it the first floor of my controller. So we have 2 power supplies. This is 12 volt 5 amps power supply that gets power from the mains, and then there is a relay sitting here that is controlled by the switch, by the trigger in the gun, and when we depress the trigger, the relay activates and provides 12 volts to the vacuum pump. The vacuum pump is most compact but most powerful pump I could find that fits into the project. It says VNC4. They come in 2 flavors, with brushed and brushless motor. This is the brushed motor, so I think it's a little bit cheaper. It says vacuum minus 85 kilopascals and flow 40 liters per minute. I think that should be plenty for the soldering purposes. Now there is one more thing hiding here underneath the pump, and what is hiding here underneath the pump, the current limiter. It's one of the current limiter boards that you can buy for a few dollars off the net. That basically limits the current on motor start, because when this motor starts, this vacuum pump starts, it can draw a lot of current, or it can attempt to draw a lot of current, and basically a circuit protection in the power supply was activating, and things were not running smoothly. So that's why I fitted this circuit here. It is set to 4.5 amps. Normally this motor will run at around 3.2 or 3.3 amps. That's the continuous current requirement for the vacuum pump. so that limits to 4.6 amps. That should be stopping power supply, this 12 volt power supply, complaining about overcurrent current. And then we have a small switching power supply that sits here. It's also connected to mains, so it's separate from anything else, and it provides 5 volts. 5 volts for the Arduino and max 6675. It is one of the USB power supplies that I have that I had around, and basically I converted it from the wall plug to the wires going into it. And here we have wires going to the mains, and then the ground floor and the enclosure. That's how it looks like. Let's zoom out a little bit. So that's how it looks like. So the front panel is going to sit well in the front, so here, and then the first floor of this device will be sitting here, here on top of what is what's already there. It still needs a little bit of work to get things sorted here. Essentially we have two things here, well, three things here really. This is 18.5 volts, 6.5 amps power supply, so quite powerful. Contrary to what the description here says, 24 volts, 80 watts. It is really drawing much more current. At 16 to 18 volts it can go up to well beyond 6 amps on the cold element. Obviously as the element heats up, the resistance goes up, and then it settles around 5 or just above 5 amps. So it is approaching this 18 watts for 16-18 volts. But I wouldn't recommend running these guns from more than 18 volts. I think ideal temperature is somewhere between 16 and 18 volts. If I could find, I would probably use 16 volts power supply. That's what I've got. I get 18.5 volts. You need quite powerful power supply, and then it's connected to the mains, so it's on when the switch is activated, and then goes to this little circuit. I hope you can see this here. There's lots of wires. It's going to be a little bit more tidying up. There are some LED indicators that will be going to the front panels and things like that. But basically what it is the MOSFET logic level MOSFET transistor sitting here, and the output of the power supply is connected to the drain, to the positive terminal of the power supply and the drain of this MOSFET, and this is going to be connected to the Arduino. This is the wire to the gate, and this will switch on or off MOSFET through 100 ohm resistor, as requested by the controller. The sidewalls are not quite sort of like coming to the bottom board. There is a little bit of ventilation here. You can see here there is there are holes. I'm planning to drill some ventilation holes on both sides here, so there will be some airflow through this construction. So power supply, MOSFET, circuit, and then third element is this wire that will be connected through to mains, and the mains cable, will be going in through this corner, connecting all the mains requirements. And that's basically the overview of this controller. Now what I need to do is to put it together, and hopefully it's going to work as I expect it to work. There is the vacuum pump causes lots of vibrations, so it is suspended. It is mounted on the rubber base. There is also some rubber support here. Hopefully this is going to dampen a little bit these vibrations, and the support for this first floor is also on the rubber. I need to figure out how to connect this base for this first floor to this support. All the parts are ready to be assembled. The ground floor part. So once again, PSU. There is in this section isolated high voltage mains distribution that goes to the PSU, and then to this PSU and this PSU. The MOSFET sits over there. It's wired to the socket. Here is Arduino Nano OLED display, switches, potentiometer, max converter for the K-type thermocouple. There are also some wires that will be used for the project to build yet another desoldering tool apart from the gun. Pump, I've already mentioned about PSUs. Here is a relay that switches on the pump, and then there is a current limiter sitting under the pump, and as I said, some additional wires here, 5 volts output that will be used for another Arduino that will be sitting on top of it, and I'll explain probably in another movie when this project finishes what is going to happen there. There are some LEDs wired in various places for this project, so I have better understanding of what's happening. Here is the vacuum connector ready, and now it's time to just put everything together and test it. Description of the parts and how they are connected. Everything starts with the mains input. So this is AC mains, and we have a switch here on the live wire, this neutral wire, and then the live wire goes into 3 switching power supplies. Here we have 18.5 volts, 6.5 amps power supply for the iron heating element. Here is 5 volts, 1 amp switching power supply for Arduino and all the boards like display and temperature decoder. And then we have a third power supply, 12 volts, 5 amps switching power supply for the vacuum pump. And obviously the live goes to every part here, and then we have neutral that also goes to every power supply. So that's our power supply arrangement. Most important is the 5 volts. Well, all are important, but the most busy is the 5 volts 1 amp. So we have plus 5 volts coming out of it, and the other going to the ground. And here we have obviously plus and the other going to the ground, and the grounds of these 2 power supplies are connected. So as I said, this is the main one for the Arduino. So that's the Arduino Nano board. And Arduino is connected to display. So we have OLED 1.3 inch display, and that's that essentially works out of I2C lines, and we have and we have 5 volts coming into it. That's plus 5 volts coming through the Arduino. Then we have Max 6675 thermocouple decoder board, and that's connected to the SPI interface, so 3 wires, clock select, chip select, sorry, MOSI and clock, and that also gets power plus 5 volts from Arduino, plus 5 volts, and then it's ground here, obviously connected together, and there is ground connected here. And then we have three more actually devices that outputs and outputs inputs used on the Arduino. One is simple switch on a digital pin going to ground, and that is standby switch, and if I remember correctly it's D3. Then we have a potentiometer that is connected to plus 5 volts and ground and A0, and that's temperature setting, A0 or A1 actually. So that's also going to 5 volts. And then we have one more digital pin used for the MOSFET that controls heating element. So that's connected to the D2 through 100 ohms resistor going to the gate of the MOSFET, and then we have N MOSFET. Here is source, and here is drain. So that's MOSFET N, and it's logic level gate. Here is our socket that connects to the soldering gun, and pins 1 and 2 are going to the thermocouple. So pin 1 is positive lead of thermocouple, and pin 2 is negative lead of thermocouple. Yeah. Then we have 2 pins 3 and 4 that are connected to the heating element. So here it goes on the positive to the pin number 4, doesn't matter, and then here it goes back to the MOSFET. So the MOSFET basically closes the circuit when there is voltage, positive voltage at the gate given by the Arduino. Between the gate and ground here is 100k resistor. This potentiometer, by the way, is 10k. So I hope that is more or less clear what's happening here. And then finally we have a circuit for the pump. Here there is no plus minus. Here this ground is not connected and not common with the other two. This goes to the relay. So that's relay. From the relay there is another board here that is current limiting board, and this is connected to the vacuum pump motor. So that's vacuum pump. The current limiting board is here for the motor not to take a lot of current, because what was happening is the switching power supply was switching off. Basically, circuit protection was activated when the motor was starting. The maintenance current required by this 12-volt vacuum pump is 3.2 amps, right, roughly. So perfectly within the specs of 5 amps power supply, but at the start it was going quite high. So I used a current limiting board, and this current limiting board is set at 12 volts and 4.6 amps. And then we have 2 pins here to activate the relay, so pin number 5 and pin number 6, and that's basically going to the positive. I'm going to, for illustration purposes, I'm going to put this switch here, but obviously the switch is actually in the well, that's not the switch, that's the relay coil. but the switch really is in the gun itself. So that's from the positive going here and then coming back and connecting to the negative side. Actually, this is not going through the relay, but it's going the negative wire, negative voltage ground goes around the relay. Obviously, only positive goes through the relay, so that's wrong here. What is happening here and how this is sort of like wired between the mains input and the socket. That's what we've got, and these are all these controls here on the front panel. So socket, the vacuum pump sits here on top. There's current limiting board under the vacuum pump. Here is the 10K potentiometer. Here is the switch that is activating standby. Here is OLED display. The max 6675 port is here behind the front panel, and also the MOSFET circuit is here behind the panel. The power supply is on the ground floor for the heating element. The power supply for the Arduino Nano is here next to the vacuum pump, and 12-volt power supply for the vacuum pump is here at the back of the upper floor of my desoldering gun controller. So that's essentially the diagram of connections inside that. I'm going to connect right now the gun. So this plug goes in here, and obviously the suction vacuum pump goes here, and here we have a gun, and here is the temperature, and I'm going to test temperature here at the tip of the gun. So I'm going to switch on, and there are 5 LEDs. I didn't show these LEDs on the diagram, but basically that indicates that the 12-volt power supply is working and the 18.5 volts power supply is working. This LED shows positive voltage at the gate, the MOSFET gate. That shows the drain to source, and the MOSFET is conducting current. There is a current there, and that shows the voltage going to the vacuum pump. So that's what this is showing right now. It is in the standby mode, so it is showing the standby. This is the temperatures being read from the thermocouple in the gun. It's not very accurate at the whole, I would say, range, and I'm going to explain a little bit later. But it should work reasonably well for the higher temperature, for the temperatures that this gun is supposed to work. So at the moment it is showing 13 degrees here and 23 degrees. This is the real temperature of the tip here. But it's going to be slightly better accuracy when it's at the higher temperatures. So we switched it on, and we can see gate and voltage is a gate, and a drain source is current is going in. So there's voltage and current going through there, and the temperature is going up, and you can see that there is a temperature increasing already both at the tip and the thermocouple inside is showing temperature going up. So I said 330 degrees. I'm going to see how effectively it's going to reach there. So it is definitely going up quite quickly. I mean, there's probably about six, somewhere between 5 and 6 of amps of current going through this heating element, which is and there's well above 100 watts being delivered to the gun at the moment. So right now we are within the range, and then the heater is off. The LEDs, the MOSFET LEDs are off. We can see the tip temperature is still trying to catch up. Hopefully it will go there as the temperature between the heating element and the tip equalizes. So inside the thermocouple, the temperature is already sort of like dropping down slowly, and here we reach 330 degrees that I set here. So you can very clearly see that that is exactly as it should be, and it's around 330. So it is now. It is simple bang algorithm. I didn't do any PID algorithm or anything complicated. I'll show you the code in a moment. Arduino sketch in the moment. But basically it is the heating element is off when the temperature goes 10 degrees below the set threshold, and it's off when it goes above 5 degrees from the set threshold or set level. And that allows the temperature to stay plus minus 10 degrees. So that's, for me, that is enough accuracy for any soldering work. I don't need really to maintain temperature to the 1 degree accuracy. So as you can see, it is more or less sort of like maintaining temperature where I want it to be. Let me take you through the Arduino sketch. It's quite simple, so I only give you an idea of how it is put together. I use 5 libraries, SPI and I2C communication library, then libraries driver for the OLED display and graphics library, and then finally library for Max 6675 temperature decoder, thermocouple temperature decoder. Then we initialize the display, then we define some pins for the SPI communication, and we initialize Max 6675. And then we have some code to convert the temperature from what Max 6675 is reading to the actual temperature. And that's the reason why the temperature read by the station from the gun is not 100% accurate on the whole range of measurements. So it works more accurately at the higher temperature. The reason for that is that the thermocouple used in this gun is more like E-type thermocouple rather than K thermocouple that is being decoded by the Max 6675. So I need to convert what max 6675 is reading into E-type temperatures. Otherwise, the temperatures were much higher than the real ones. So we have two functions to do that in the code. First, we convert what is being read to millivolts of the thermocouple. So we convert temperature to millivolts, and then we convert those millivolts back into temperature, but for E-type thermocouple. Very simple calculations, not something that is I didn't use polynomials or any complex math. It is really very simple conversion, and that's why it's working best for the temperatures in the range of 300 to 450 rather than much lower temperatures. Then we have in the setup part, we have mostly display that is being initialized and some pins defined, some delay for everything to stabilize, and the loop part of the sketch, we read the temperature that is set by the user from the potentiometer voltage divider, and then it is converted into the temperature setting. It is rounded to 5 degrees, so the accuracy of setting is 5 degrees. And then we do this reading from the thermocouple in the gun. We convert to millivolts what we read, and then we convert back to temperature using E-type thermocouple model. And then finally we display everything on the screen, and also we have some conditions here to decide whether our digital pin output is positive or negative, whether we activate MOSFET or not, or we basically switching heating element on or off, and that's essentially all code. So quite simple.